A bag contains tomatoes that are either green or red. The ratio of green tomatoes to red tomatoes in the bag is 4:3. When 5 green tomatoes and 5 red tomatoes are removed, the ratio becomes 3:2. How many red tomatoes were originally in the bag? So the amount of green tomatoes is 4 times a number x. The amount of red tomatoes is 3 times the number x. And that can be written as this ratio. So when we take away 5 from each bag, we're left with the ratio 3/2. So now we can just cross multiply this, solve for x, and then plug that back in to the number of red tomatoes. There are 15 original red tomatoes. If each digit in an integer is greater than the digit to the left, the integer is said to be monotonic. For example, 12 is a monotonic integer since 2 is greater than 1. How many positive 2-digit monotonic integers are there? So for 2-digit integers, that's from 10 to 99. So let's start with 10 to 20, and there we have 12, 13, all the way until 19, which is 8 integers. Doing the next group, 23, 24, all the way to 29, and that's 1 less than the previous 10, which is with 7 integers. So for the next group and onwards, we're going to have 6, 5, 4, 3, all the way down to 0. So adding that up, plus 2 plus 1 plus 0, we end up with 36. So there are 36 of these type of integers. For a particular number a, the first term in the sequence above is equal to a, and each term thereafter is 7 greater than the previous term. What is the value of the 16th term in the sequence? So the first term is a, and the second term is 7 greater than a. So just solving for a, we have then the 16th term on this pattern is going to be 16a minus 15, like we see above. And we just plug in 8 for a that we already solved for. We got 128 minus 15, and that's 113. If p is a prime number, how many factors does p cubed have? So we can choose any prime number we want to do this. So if we choose 2, we want to see how many factors 2 cubed has. That's 1, 2, 4, 8. This works for any prime number you're going to choose. So for p and p cubed, the factors are going to be 1, p, p squared, p cubed, which is 4. How many integers between 10 and 500 begin and end in 3? So between 10 and 100, just looking at 2-digit integers, there's 33 in that set. Then for the 3-digit integers up to 500, it's going to be 3, something in the middle, and end with 3. That something in the middle can be anything from 0 up to 9, which is 10 digits. So this one option, plus these 10 options, gives 11 total integers. A particular integer n is divisible by 2 different prime numbers p and q. Which of the following must be true? N is not a prime number. So that's true, because by definition of a prime number, n should only have divisors 1 and itself. And since it's divisible by p and q, that's not true. N is divisible by p times q. That's also true, because it's divisible by p and q. So 6, for example, is divisible by 2 and 3. n is an odd integer. That's not true. The example I just gave with 6. So it's C. A perfect square is an integer that is the square of an integer. Suppose that m and n are positive integers such that mn is greater than 15. If 15mn is a perfect square, what is the least possible value of mn? So square root of 15mn has to be an integer. The only way for that to happen is if we break down 15 to 3 and 5, we need something that can be taken out, so 3 squared times 5 squared. So if m is 3 and n is 5, that gives us a whole number. But that leaves us with mn equal to 15, which doesn't work. So we can introduce another number. Maybe m becomes 3 times 2 and n becomes 5 times 2. Then the 3 comes out, the 5 comes out, and the 2 comes out. We just saw that 1 doesn't work. It's too small. So the largest is 2, and that works. So 3 times 5 times 2 works. That's a whole number. For the value of mn, 6 times 10, 6 times 10, which is 60. That's the least possible value. M is a set of 6 consecutive even integers. When the least 3 integers of set m are summed, the result is x. When the greatest 3 integers of set m are summed, the result is y. Which of the following is true? Okay, so let's just pick random numbers. 2, 4, 6, 8, 10, 12. These total to 12. These are 30. So this isn't true. That isn't true. That isn't true. But we're left with these 2 options. So let's try the next set. And this gives us 18 and 36. So that's no longer true. So the only one that works is B. And you can just choose any set of integers. A 3-digit number x, y, z is formed of 3 different non-zero digits x, y, and z. A new number is formed by rearranging the same 3 digits. What is the greatest possible difference between the 2 digits? So for the greatest possible difference, we want the difference between the first and the last to be the most. And we're going to achieve that by having one as 1 and the other as 9. In between, let's guess. That gives 792. Okay, so let's try a different one for the middle. And that also gives 792. See, it's going to give the same result because these just subtract to 0. So the largest difference is going to be 792. An integer is subtracted from its square. The result could be which of the following? Okay, let's take an integer, its square, and subtract the 2. This is not negative, it's not odd. It's the product of 5 and 6, but those aren't both even or both odd. But it is the product of 2 consecutive integers. So let's try with a different one to see if that still works. So 7, 49 is its square, 42 is its difference. And that's the product of 6 times 7, so that adds up. Answer is E. Let m be an even integer. How many possible values of m satisfy square root of m plus 7 is less than or equal to 3? Okay, so for it to be equal to 3, m equals 2. That gives us square root of 9, which is equal to 3. Now for the smallest it could be, it can't be negative, because it's a square root, so it can only be 0. The smallest m could be is negative 7, but it's even, so -6. Now, the possible values of m could be anywhere from -6 to 2. So it's -4, -2, and 0, which is an even integer. That's 1, 2, 3, 4, 5 options. Let x in a box be defined by x plus 3 over x minus 1 for any x such that x is not 1, which of the following is equivalent to x minus 1. Okay, so let's just subtract 1 from x in a box. Making a common denominator with x minus 1, these two are equivalent, and that leaves us with x plus 3 minus x plus 1, these two negatives become positive, over x minus 1. The answer is 4 over x minus 1. Let a and b be numbers such that a cubed equals b squared. Which of the following is equivalent to b squared root of a? So, a, using this, a is equal to b to the 2/3. Just remembering exponent rules. So, the square root of a can also be written as a to the 1/2. And using this information, that's equal to b to the 1/3. So, b squared of a is b times b to the 1/3. And this b can also be written as b to the 3/3, because that's just b to the 1. And when you're multiplying, you add the exponents to get b to the 4/3. Let m and n be positive integers such that 1/3 of m is n less than 1/2 of m. Which of the following is a possible value of m? So 1/3 of m is 1/2 of m minus n. So let's simplify this, making common denominator to combine these two terms. That leaves us with negative m over 6 is negative n, or m equals 6n. Now we can't find the exact value of m because there can be several, but we know that it has to be divisible by 6 because these are positive integers. The only option in this list is 24, because that is divisible by 6. If a and b are numbers that such that a minus 4 times b plus 6 is 0, then what is the smallest possible value of a squared plus b squared? So for the solutions to this, a can be 4, b can be anything, or a can be anything, and b can be negative 6. Because in either case, one of these terms is going to equal 0, and the equation is going to equal 0. So, if we have b equals negative 6 and a equals something, that is going to give us a larger result than if a were to equal 4 and b is equal to something. See, because that would be a squared plus 36 versus b squared plus 16. So let's take out that possibility. Now the smallest possible solution for this is just b equals 0. So the smallest possible value is 0 plus 16. Let f of x equal ax squared and g of x equal bx to the 4th for any value of x. If a and b are positive constants, for how many values of x is f of x equal to g of x? Okay, so if f of x equals g of x, then ax squared equals bx to the 4th. Now, one of these values is obviously going to be x equals 0. We have 0 equals 0, that works. Now if we want to simplify divide by x squared, we have a equals bx squared. Solving for x, that gives square root of ab and negative square root of ab. That's 1, 2, 3 solutions. Let a and b be numbers such that 30 is less than a, less than 40, and 50 is less than b, which is less than 70. Which of the following represents all possible values of a minus b? Okay, so for a, the upper bound is 40, and the lower, the smaller one, is 30. For b, it's 70 and 50. To find the largest value, we're going to take of a minus b, we're going to take the largest of a and the smallest of b. That's going to give us our largest a minus b, which is negative 10. For our smallest value of a minus b, we're going to take the smallest value of a minus the largest value of b. That's going to get the smallest number we can have, which is negative 40. So, a minus b has to be within those bounds.